Hey Trig, I know this is labeled 7-4, but I wanted to end some of the 7-3 notes I didn't get to. This is just an application of the law of cosines. We have these three sides given to us here. We want to find angle B for the truss. And so you would use the law of cosines to find that. I just wanted to give you the answer. You should get about approximately 33 degrees. Use the law of cosine, see if you can get that. If you can't, come to class and ask me to go over that. Okay? You should be able to. Or it's worked out actually for you on page 315 of your textbook. Here is just guidelines, suggested procedures. Okay? Whether you know the side angle or angle side angle, what you would do. If you know side angle or angle side, that's the yucky one, right? The one that, it's going to be a pain in the neck. Here are two sides and the included angle and three sides. Okay, just ideas on how to solve those. Heron's formula was derived using the law of cosines. That's why it's in this section, okay? But we don't actually use any trig for it, okay? But it was derived. That's how this Greek mathematician, look when, this is back 75 AD, and they were working on this kind of stuff. Anyway, every triangle has something called a semi-perimeter. You add the sides and cut it in half. Add up the sides of the triangle, cut it in half. They found that the area, using the law of cosines, they derived that the area of any triangle is the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. Okay, so again, if you want to see how that was derived, that's on page 317, and that's what uses the law of cosines. However, it's a great formula to use, guys, because you don't need a height. Every other time we needed to find the area of a triangle, we had to take 1/2 base times height, and sometimes we had to finding that height's difficult. Now, as long as I know three sides, I'm good. The distance, as the crow flies, from LA to New York is 2451 miles. From New York to Montreal is 331 miles. And from Montreal to Los Angeles is 2427. If we want the area of this triangular region, I don't know the height, but now I can use the formula. I just need to find the semi-perimeter, which is 1/2 2427 plus 331 plus 2451. Just add up all the sides and divide by 2. You get 2604.5. Okay, now that I have that, I'm going to take 2604.5 and subtract 2427. Okay, when I subtract 2427, whatever I get here, I'm just going to write it so I don't have to. Okay, 2604.5 minus 2427 times, I'm going to take 2604.5 minus 331. And then I'm going to take, 2604.5 and subtract what else, whatever I didn't get, 2451. Okay, so I do all that, multiply it all together, take the square root, see if you get about 401,700 square miles. Okay? All right, so I didn't get to, I just wanted to finish that up. I think that was it. Yeah, that was 7-3. I apologize that I did not get that all done. 7-4. We go into something called a vector. Okay, I don't know if you've heard the word vector before. Maybe you heard it in this little clip here.
I'm applying for a new film loan. Go by the name of Vector. That's a mathematical term, a quantity representing an arrow with both direction and magnitude. Vector! That's me. Is that many times with both direction and magnitude. Oh yeah! Check it.
Okay, vector, magnitude, and direction. That is what a vector is. The length of the line segment is the magnitude of the vector. Okay, the length of the line segment is the magnitude. The direction, well, is designated by the arrow, which way it's pointing. Okay, so this vector represents a force of 10 pounds. Okay, so this is a length of 10 and applied at an angle of 30 degrees above the horizontal. Vectors are sometimes named with just one letter, sometimes two letters. It's kind of confusing. Sometimes uppercase, sometimes lowercase. So you just kind of have to look. Like they would just say vector OP, vector PO. They don't remember how we used to do with lines. We'd have like a PO, and that would be array. If it was like this, it was a line. We don't really do that with vectors. We just write vector OP, vector PO, okay? We are going to add vectors. When we add, here's vector A. When I add vector B to it, what you actually do, guys, is take vector B, okay? You put it right at the end of where vector A is, and then the sum of A and B is when I start at the initial part of A and go to the ending of B. Okay, right here. There you go. There's the sum. This is the answer to A plus B. A plus B equals this. Okay, there's the direction. Oh, I should have put an arrow. Sorry. A plus B is this vector. Okay. So, for example, here was A. Here's B. You have to make sure you put B's, you don't compromise its direction, okay? And then the sum of A plus B is this vector. Place the initial point of vector B at the terminal point of vector A, okay? So the initial point of vector B is at the ending spot or the terminal point of vector A. The sum is this vector, A plus B. Okay, so I want you to try this. You can pause me and try this. I'll put up the answer here shortly, but these are the three different ways that we're going from Spain traveling west. Okay, draw one vector for each month of travel using a red pencil. In what country will you make landfall? Your ship can sail 10 squares per month, starting from Spain and traveling west, which is a bearing of 270 degrees, right? If I'm here, 90 degrees would be, oh, whoops, sorry. Okay, a bearing of 270 degrees. So we're going straight across here. Okay, how many months will be to reach that? Okay, so go ahead and draw that. Let me show you what we have for that. So I'm starting here. Here's the first vector. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, second vector. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I can go 10 squares a month. Third, another vector, 1 to 10. And then I took 1, 2, 3, 4, 5, and I made landfall. Okay, So the solution then was 3.5. Okay, it's going to take me 3.5 months. How many months will it take to reach land? 3.5. Okay, where am I going to end? In USA. Okay, now, unfortunately, the wind does not always blow the way you want. To determine how the wind affects your travel, we're going to include a wind vector. First, draw your ship vector just like in part 1 using your red pencil. Now, at the end of that vector, add the wind vector using the blue pencil. Okay, so month 1, we go after 1 month, we go 2 squares south. So in other words, I'm going to take my red pencil now, okay, and I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I still went 10, but now the wind blew me 2 south, okay, 2 squares south, okay. Then I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I go 10 the next month, but then the wind blows me after month 2, 4 diagonal squares southeast. Then here's southeast. So 1, 2, 3, 4. So I ended there. Now I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What happened after month 3? 2 squares west. Ooh, that's helping me, right? Nice. So actually I'm here. Okay, and then after month 4, there's no wind. Oh, okay, so I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I ended up landing, but I landed in Florida instead, and it took me 4 months. Ended in Florida, but it took me 4 months. 1, 2, 3. It ended up taking me 4 months to get there instead, and I got shifted down. Okay? Anyway, just to give you an idea of that, can you try the other one? And I'll draw it up here, but you try it on your own. Pause. Okay, to see how this looks I didn't have the diagonal part in before, but we got the wind, same wind as the first problem, but now we also have the current. Okay, so this would be the sum. This would be actually what it looks like, how the ship is going. Okay, I know we keep drawing the red ones just to see, but this is how the ship is going with the wind and the current. Okay, and then we had that same 4 diagonal wind, but we also had a current pressing us to the west. Okay, so I start from the beginning here with the end of the green. This is what that looked like that way. And then the last one was the wind and the current shoving us right to Cuba. Okay, anyway, a little bit of a look at what it looks like for how vector addition affects across the ocean. Parallelogram rule is another way to add vectors. If you don't like just putting it at the end, you can just make a parallelogram, put your A and B together right at the same initial spot, and then draw a parallelogram and draw the diagonal of the parallelogram. And that's another way to get the A plus B, okay, if you want to add them together that way. Okay, negative V is the same distance, but the opposite direction. Okay, so here's B, here's negative B. So instead of subtracting, that's what we do. We add the opposite vector, which kind of makes sense. This is what A plus negative B would look like with the parabola method of addition. Okay, so that's just a little intro into vectors, and I wanted to end up 7.3. So the next video will just be the rest of 7.4.